So today I'm going to explain about that insertion algorithm, insertion operation in a red black tree, and these are the this is the insertion algorithm, this is the insertion algorithm, and this is the property of the red black tree. So we'll see that what is the insertion algorithm of the red black tree, and we can also say that the construction of the red black tree. Right. So now he is saying that if the tree is empty, we'll create a new node as a root node, and that color is black. So this situation is only for the if tree is empty. Next step is saying that if tree is not empty, means suppose there is already some element is inserted, and then after you want to insert the new node, then that color will be the new node. The color will be the new node. Third step is saying the parent of the new node is black. While inserting the new node, suppose I am inserting the new node, I'll check there. If it is new node, always we will insert the new node, that color is red only. So whenever we will insert the new node, that color is red, except that if tree is not tree is empty. Except this first situation, if tree is empty and then you are inserting the element, that will be the red, black color. Remaining that if tree is not empty, then whenever you are inserting the new element, that color will be the red. Then after, while inserting the red node, then you have to check that their parent is black or red. If it is black, you can stop there, no need to check the fourth step. Why so? Because the property of the red black tree, if you go and check that property of the red black tree, they are saying that no two adjacent nodes should be red. There will be two adjacent node color red is not allowed in the red black tree. Because of that reason, you have to go for the fourth step. But here is saying that if their parent is black, it means that there is no two adjacent node color is red. Then you stop here, not required to check that fourth step, right? Fourth step, when you go for the fourth step, if it is two node, means if two adjacent node, means a newly started node and the parent node, both color is red, then you go for the fourth step. Now I'm going to explain this steps using the using example, so you better understand. So now there is some array is given. Now I'm going to construct the red black tree using this given array, and I will going to insert one by one element, and I will going to construct the red black tree using this algorithm, and also I will check that it is following the red black tree property or not. So now we'll see that what is that here. Fourth step is saying that if color is black or null, if the better to I'll explain with the example. Okay, so 41 come in starting, there is no element, means tree is empty. So if the tree is empty, that 41 is act as a root node, and that color is black because of the first step of the insertion algorithm is saying that if tree is empty, the new node act as a root node, and the color is that black. So 41 is the black. Now 38 come. So now I'm going to insert 38, and I also told that red black tree is the binary search tree. So the insertion operation is like a binary search tree only. One extra term is that here coloring is required. So here we'll do the color. So we'll see where 38 is going to insert. So 38, here tree is not empty. So the 38 color will be the red. Now we'll check that where 38 is going to insert. So here start from the root node. Is 38 less than or greater than? So less than. So 38 is going to insert left children of 41, and 38 color will be red because tree is not empty. So now I have inserted 38 and color also have given. Now we'll check that the third step, if parent of the new node. So new node is what here? New node is 38 and their parent is 41. So 38 parent is 41 and the color is black. The third step is saying that the parent of the new node is black, then stop. So not required to perform any rotation, coloring, nothing required, because it's a valid red black tree because their parent is black. So not required to go for the fourth step. Right? So 38 inserted. Now I am going to insert 31. Suppose if I am going to insert 31, again check that binary search tree procedure. Start from the root node. 31 is less than 38. Yes, less than. So go to the left part. Is 31 less than 38? Yes. So that left children 31 is going to insert left children of 38. So 31 is inserted, and I say that every time the newly inserted node color will be the red. So 31 color is red. So this color is red. Then what will you do here? If you see here the property of the red black tree, it's saying that no two adjacent nodes should be red. But here if you see the parent of the 31 is also red. If it is black, we will not going to check the fourth step. But here is saying that 31 parent is red. So in this situation, this is the violation occur. This is the violation occur, that in this situation we'll go to the fourth step and we'll check that what can do. So we'll get the valid red black tree. Right? So here saying that the parent of the new node is red. The parent of the new node was 31 and their parent is 38. Their color is also red. So this is violating. Then check the color of parent sibling. 31 parent is what? 38. And their sibling is what? Their sibling means what? The sibling is nothing but the same parent children is called sibling. So 38 parent sibling they are checking. They are not saying that their sibling. 31 sibling not asking. They are asking that parent sibling. Parent sibling, if you consider the real life example, it means that suppose this is the son, and this is the father. And father is called grandfather. Father is called grandfather. Right? So father children, suppose this is the some father children it is. Father children, assuming here I am null. Right? So here father children is that some uncle. This father children is called uncle. Father children is uncle. Right? But father sibling, this is father sibling. Null is nothing but a father sibling. Here null is father sibling, means there is no son. Right? So you have to check the color of uncle. You have to check the color of uncle. The fourth step. Just give me 1 minute. I'll erase it all that. And for that, so here if you go the fourth step, here saying that if the parent of the new node is red, then check the color of parent sibling. Parent sibling is nothing but a uncle. You have to check the color of uncle. If it is uncle color, there is a two step. Either will be red or either will be black. Or either third step will be null, means there is no uncle. Right? So here saying that if the color of the uncle is black or no uncle, means null, then you perform rotation. If uncle color is black and null, it means that no uncle, then you perform rotation. And if it is your uncle color is red, then you perform recolor. Right? But here which situation it is? 31 you have inserted, the color will be red because newly inserted, and their parent is also red. Now you check the uncle color. What is the uncle color? Because here there is no uncle. Because of that there is no uncle. It means that null. Then in that situation what will you do? You have to perform rotation. You have to perform suitable rotation. And that suitable rotation is nothing but a ABL tree rotation. There is a fourth situation. You got that which situation? LL situation, LR situation, the fourth situation LL, RR, LR and RL. So this four situation you will get that, and that rotation you have to perform. And one more thing is saying that recoloring. You have to perform rotation as well as you have to perform recolor also. Right? So now I am going to tell you that how you perform recolor in that all four situation. And so here is that which situation it is? It's LL situation. It is LL situation. So if it is LL situation, what you are performing? Which rotation you are performing? Right rotation. And that too from mid node. So if you perform rotation from the 38 to 41, you are only performing rotation between 38 41. 31 is as it is. 31 we were not doing anything with 31. 38 become root and 41 will come down. 41 will come down. And their color is what? What is their color? I'll just erase it. So here is that if I'm saying that performing here situation is what? If it's here situation is that LL situation. This is LL situation, right? So you are going to perform rotation from what? 38 to 41, right? So 41 will come down, and 38 become root. But 38 color was what? Red, and 41 color was black. But this is again violating the property two adjacent. So here is saying that you have to perform suitable rotation as well as color, as well as you have to recolor. And recolor, which node will you do recolor? So in this situation, how you perform recolor, you are performing rotation between 38 and 41. So you have just swapped between these two color, 38 and 41 color swapping, you do that. So now this 38 become black and 41 become red. 38 become black and 41 become red, and afterward you get this final tree. You will get this final tree. So I hope you understood. Now I'll explain you that other situation. If it is in this situation, you will get it while performing, while constructing the red black tree, you will get it like this is the LL situation. Might be you will get an RR situation, LR situation, RL situation, you will get it. So I'll explain you that how you perform the coloring, recoloring. Rotation, I think you are aware of that. If you don't know rotation, you go and check that AVL tree, in introduction of the AVL tree. There I have already explained that all these rotation, how you perform rotation. I have also explained that shortcut method. Here I am just explaining you that how to perform recolor. Right, so here is that one element, and you have inserted newly element is 3, newly element is 3, and I said that newly element color is that red, and that color was also red, right, and this was the black. Blue is black, and 2 is red, and 3 is red. So this is the red. So again here the violation occur. Here is the violation occur, and if you see that the situation, if you look at the situation is that what situation it is? Its situation is that RR situation. This situation is that RR situation. So what will you do in this situation, right? So if it is this situation, you will get it like that. If it is you are getting this situation, you consider that the blue is the black, and this color is the red, orange color is the red. So here RR situation, in that situation what you were doing that? You were doing that right rotation, sorry, left rotation, and that too from mid. Mid means you are doing rotation between 2 and 1. You are performing rotation between 2 and 1. So 1 will come down, 1 will come down, 2 will root, and 3 is as it is. 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 So earlier the 2 color was what? Red. Earlier 2 color was red, and 3 is red only, and 1 color was black. 1 color was black. Now what will you do? You have to perform swapping the color also. You have to perform swapping the recolor, because you are performing recolor. You have to also perform the swapping the color, right? So you have to perform swapping the color between 2 and 1 only. So 2 color was previously red, now it will become black, and 1 color was black, now it become red. This you do if it is RR situation. Now if it is this is LR situation. If it is LR situation, here also violation occur. There is a 2 red. This is also red. This is also red. So here also violation occurs. So if it is LR situation will come. If it is LR situation will come, in that in shortcut method you are making that whatever the last node that will become the root node, that will become the root node, and root become the right children. So you are doing like that, you are getting like that what? 1 become root and 3 become the right children, and 2 is left only. 2 is the left only. So you are not doing anything with that 2. So here the swapping color between the 3 and 1, the swapping color between 3 and 1, right? So one color was red, so now this is become black, and 3 color was black, so that become the red, and 2 is still red, right? So this is for the LR situation. What about the RR situation? So here also the recoloring, if you do recoloring, so decoloring between the 2 and 1, the last node with 1. If it is LR situation and RR situation, do remember, if it is LR and RR situation, there is a 2 rotation you are going to perform. So their color swapping between the last node and root node, and for the RL also last node with root node. But if you are getting the RR and LL situation, their coloring swapping between the middle node and root node. Here middle node and root node. Do remember, this is the shortcut method, then you can easily understand the remaining part. Okay. So here if you do recoloring, you will get it there, and here we are performing rotation between 2 and 1, means 2 become the root, 2 become root, 3 is as it is right children only, and 1 become the left children, and color will be changed between 1 and 2. So 1 was black, so 1 become red now, and 2 was red, so 2 become black, and 3 is red only. So I hope you understood all the rotation and how you recolor it. Now we are going to insert the remaining elements. So I have already inserted 41, 38 and 31 I have inserted. Now I am going to insert remaining element. So if I'm going to insert 12, now if I'm going to insert 12, so 12, where 12 is going to insert, I will start checking from the root node. 12 is less than 38 or greater than 38. So 12 is the less than 38. So come to the left part. 12 is less than 31 or greater than. So less than. So 12 is become the left children of 31. 12 is the left children of 31. And I've already said that always whatever the new element you are going to insert, that always be the left, red color. Always be the red color. So if you look at that, the two adjacent node, two adjacent color is red. The fourth step, if you go with the fourth step, is saying that the parent of the new node is red. The parent of 12 is new node and their parent is 31. So if it is this situation will come, you check their uncle color. So 12 uncle is what? 12 parent is 31 and parent brother is that 41. So 41 become the uncle of 12. So you have to check that color of the uncle color. You have to, when you have to insert the newly node and color is red, then if it is going to violate the property, then you check the uncle color. So uncle color is here red. So if you look at here, he is saying that the color, if the uncle color is red, if the uncle color is red, then you perform recolor the parent, uncle, and also check the grandparent of the new node. And if it is grandparent of the new node is not root, then recolor it and recheck. Means saying that if it is parent color is red, if parent uncle color is red, parent also red and their uncle is also red, then in this situation you perform recolor. If it is black or null, then you perform rotation and recolor. If it is uncle color is red, then you perform what? You perform recoloring. Recoloring means that whatever the color of the parent, that will going to change now. That's black. This is black. Next, what will you do? You have changed the parent color and uncle color. Then also saying that you have to also check the grandparent. And if it is grandparent is root, if it is grandparent is root, if the grandparent of the new node is not root, then recolor. If it is grandparent is not root, then perform recolor. If it is root, then not required to performing recolor. You have stop here. You just change the color of the parent and uncle, and here your grandparent, here the 12 grandparent is root, so we will not going to do anything, right? Now, so after this you will get this tree. You will just this tree. Okay. Now I'm going to insert 19. If I'm going to insert 19, I'll check that where 19 is inserted. So 19 is going to insert the right children of the 12. 19 is inserted. Now the color will be the red color. I have already said that whenever you are going to insert new element, new node, that color will be red. So again, if you look at that, this is violating the property. This is violating the property. 19 and 12, two adjacent new node, two adjacent node, and their color is red. So in this situation, what will you check that? You check the uncle color. You check the uncle color. So uncle is here. There is no uncle. Here uncle is null. Here uncle is null. So if it is uncle null, if the color is black or null, means either your uncle is black or null, then you perform suitable rotation and recolor. So I have already explained in the previous slide how you perform rotation and how you perform the recolor. So first you have to check that which rotation it is. So if you look at that, the rotation is that here is that this is L rotation L and this is R. So this rotation is what? LR rotation. So in that LR rotation, what I have said that you have to perform swapping between 19 and 31. So whatever the last node, that will become the root node. That will become the root node, right? So 19 become the root node and 12 is as it is left and color also red. We will not going to do anything with the 12. 12 is as it is. 31 become the right children. 31 become the right children. And I said that the swapping of the color between 19 and 31. The swapping of the color between 19 and 31 is 19 was red, so 19 become the black, and 31 was black, so 31 become the red. So after the rotation, you will get it this tree. You will get this tree. And remaining you simply add it. Remaining part you simply add it, and the color is also same. We will not going to do anything. We simply add 38 and 41, their color is also same. We will not going to do anything. So now I am going to insert next element is 8. Now I am going to insert next element 8. So if I am going to insert 8, again I will check from the root node where 8 is going to insert, and according to that 8 will insert at the left children of the 12. So 8 is going to insert left children of the 12. So if you insert the 12 in the left children, and the color will be red, because I have already said that the whenever new element is going to insert, that color will be always be red. So red is inserted, and if you check that the two adjacent, the parent of the new node is red, so it's violating the property. Then what will you do? Then you have to check, if with this situation occur, then you have to check the uncle color. So who is the uncle of the 8? Uncle 8 parent is 12, and 12 brother is that 31. So 31 become the uncle of the 8. So you have to check the uncle color. So here uncle color is what? Uncle color is red. So here if you saying that if it is black or null, then you perform rotation. If uncle color is black or null, you perform rotation. If uncle color is red, then you perform recoloring. You have to perform recolor. Here rotation and recolor. Here you perform recolor, right? So do remember that, right? So here uncle color is red, so you have to perform recolor, and that too what you have to do? You have to perform recolor of the uncle as well as parent. So you have recolor it, now it will become black, it will become black. Next you have to check what? Your grandparent. If your grandparent is root, then you stop. But here your grandparent is not root, then you have to also change grandparent color. So now this color become red. What you have to do? If your new node uncle color is red, you perform recoloring of uncle parent. Third, you check that your grandparent is root. If it is root, you stop. If not root, you recolor the uncle color, grandparent color also. So you have recolor. Then you again check that still your red black tree is invalid or valid, means again there is a situation coming, two adjacent node color is same. So here there is no situation like a two adjacent red node color red. So you stop here, you just change the parent color, grandparent color and uncle color. So after that you will get it this tree. You have changed 12, 31 color and 19 color, right? Parent, uncle and grandparent, and you just change that color. Okay, now I'm going to insert 5. So 5 is going to insert it at left children of the 8. So 5 inserted, the color is red. So again you have seen that the violation occur. Now you check that what is the uncle of the 5. So uncle of the 5 is nothing here, means null is here. So here what is saying that if it is uncle is black or null, you perform rotation as well as recolor. So check that which rotation you are going to perform here. This situation is that LL situation. So what rotation you perform? You perform rotation, R rotation, you perform right rotation, and that too from the mid node. So here the swapping of the color between 8 and 12. The swapping of the color is red, 8 and 12, because you are performing rotation between 8 and 12, right? So 8 will come down, 8 will come down, and 8 become the root. It is 12 is deleted from here. So 12 color was previously red. 12 color was black. Here it's black. 12 color is black here. 12 color is black. So now 12 color become the red, and 8 color was red. So now 8 color become black. So afterward you will get this tree. You will get this tree. Remaining is as it is. You simply add the remaining complete tree, right? So your 5 is inserted. Now I am going to insert 15. If I am going to insert 15, what will I do? If you go with the binary search tree where 15 is going to insert, the 15 will going to insert the right children of the 12. If you look at that, again two adjacent node is having red color, and that's violating the red black tree property. So in this situation what you have to do? You have to check the uncle of 15. Who is the uncle of 15? Uncle of the 15 is 5. Who is the uncle of the 15? Uncle of the 15 parent is 12 and 12 brother is 5. So 5 will become the uncle of 15. So their color is black. Their color is black. Then what will you do? Then what will you do? So if it is color is black, then red, then you have to perform what? You have to perform recoloring of parent, uncle, as well as you check that is your grandparent root. If it is not root, again change the grandparent color also, and if it is again violating the property, again do same process, right? So here what will I do? I have performed recolor. So I perform recolor means I will going to change my parent color, as well as I am going to change my uncle color. Uncle color I have changed. Now I'll check that my grandparent is root. No, my grandparent is not root, so I will also change my grandparent color. So now it become red. So I have changed that. First step I have done. What I have done? I changed my uncle color, parent color, uncle color, and grandparent color. Then if you look at that, again there is a violation occur. The red black tree is saying that there will be two adjacent node color should not be red. So here 8 and 19 both color is red. Now what will you do in this situation? What will you do? Mostly people will confused here, so try to understand. This is very much important. So if it is this situation come, then what will you do? Then you consider as a 8 as a new node. Now you consider 8 as a new node. Then check that 8 uncle. Who is the uncle of the 8? 8 parent is 19 and 19 brother is 41. So 41 become the uncle of 8. 41 become the uncle of 8. Then what will you do? Check that the color of the 8 uncle is 41 and their color is black. If it is black, if the uncle color is black or null, then what you have to do? Perform rotation. And what type of rotation? You have start checking what type of the rotation it will come. What type of the rotation it will come? Start rotation from what? 8 onwards you have to check 3 node. Right? So it is left children and this is left children. You always start from the from 8th node. From this node you check that what of the rotation it is going to perform. So this is LL rotation is going to perform. So after the recoloring you will get it this one. And then you have seen that there is again violation occur 8 and 19 in between this violation occur. Then you have to check that the uncle of the 8 is 41, that color is black. Then which situation it is? Its situation is that LL situation. If it is LL situation, you are performing right rotation. So in right rotation what you are doing? You are performing between mid to 38. So you are going to swap the color of 19 and 38. So 38 will come down. You are going to perform the rotation between 8 and 19 and 38. This is the situation. So after the rotation you will get it like that. 19 will become the root node and 38 become the right node and 8 is left node, right? And color is, I say that the swapping of the color is 19 and 38 only. 8 we were not going to do anything with the red. So 8 is still red, and the swapping of the 19 and 18 color. So 19 color was red, so now it become the black, and 18 color was black, so now it will become the red. So after the rotation you will get this form. So see that this is the after the rotation you will get it this tree. And then after remaining you add the remaining part, you have to add it. 41 is the right children of the 38. So you have to add the 41 right children of the 38. Their color is as it is. You will not do anything with the remaining part. You simply simply add it. 31 is the right children of the 19. So 31 is the right children of the 19, but 38 is right children. So 31 become the left children of the 38, right? So color will be same. We will not going to change. And remaining 5 is the left children of the 8. So 5 is the left children of 8. 12 and 15 is the right children of the 8. So 12 and 15 is the right children of 8. So this is the final tree after the insertion of the all these elements. This is the final and valid red black tree. If you check that the property of the red black tree, it will going to follow the red black tree. So do remember what we have done. We have what we were doing, that what are the things we need to take care of it. First, whatever the new node will come, if it is tree not empty, and whatever the new node you are going to insert, that color is red. Second thing is that if it is two red color, if it is two adjacent node color is red, then you have to check that uncle color. If uncle color is black or null, you perform rotation and recolor. If uncle color is red, then you perform recolor of parent, uncle, and also check that is your grandparent is root. If it is root, stop. If it is not root, you recolor the grandparent color, as well as you have to also check grandparent uncle. If it is grandparent uncle, if you do recoloring of the grandparent and that again violation occur, then check their uncle and then do same. So this is all about the insertion operation of the red black tree. I'll explain you the some application of the red black tree where you have to use. So here the application of the red black tree, we are saying that where you have to use red black tree. Mostly some people are saying that why we were learning that much tree, then what's the use of the red black tree, why red black tree come. So in the Java, if you know the Java language, in Java language there is a collection. The collection is having some data structure like a tree set, tree map, hash map, and these are the collections of the Java collections. These are the collections of the, these are the interface, I think. So there whatever the tree is used, that tree is nothing but a red black trees. Here is they are using red black tree. In the implementation, if you go with the implementation, this is already implemented in the Java. You can directly call the tree set and tree map and hash map, you can directly call. But internally, whoever is implemented tree set and tree map, their red black is used. Similar like that in the Linux kernel, there also you can use the there also the red black tree is used. For in Linux there is a command that mmap and munmap, there also red black tree is used. So these are the applications application of the red black tree. So that's all about the red black tree insertion and application of the red black tree. Thank you for the watching my video. If you like my video, please subscribe.